video, we will discuss in detail about predicates and quantifiers. Let's start this video with a question. Now, before I show you the question, I first want to mention that the context behind this question revolves around Abraham Lincoln's quote that you can fool some of the people all the time, and you can fool all of the people some of the time, but you can't fool all of the people all of the time. This statement involves many quantifiers, and so let's take a look at some of the components of the statement. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below, and make sure to click on that subscribe button. Consider the statements below. Decide whether any are equivalent to each other or whether any imply any others. So you can fool some of the people all the time. You can fool everyone some of the time. You can always fool some people. And sometimes you can fool everyone. All right, so first off, I noticed right off the bat that 1 and 3 are very similar. You can fool some of the people all the time, and you can always fool some people. This is saying the same thing in my opinion. And for number 2 and 4, I think those are saying the same thing as well. You can fool everyone some of the time, and sometimes you can fool everyone. I'm just pretty certain that both of these statements are just reverse of each other, but they mean the same exact thing. They're saying the same thing. Now, these statements are a little bit hard to wrap your mind around in some cases, just because quantification is a rather complex topic. And so the goal of these next videos is to really dive deep into what quantification is. So it would be nice to use variables in our mathematical sentences. For example, suppose we claim that if n is prime, then n plus 7 is prime. This looks like an implication. I would like to write something like, for example, p of n implies that p of n plus 7 is false. So this means that, keep in mind, p of n, we're going to define to be n is prime. Should have clarified that. But this is not quite right. For one thing, this sentence right here has a free variable. That is, a variable that we have not specified anything about. It is not a statement. A sentence that contains variables is called a predicate. So this right here is a predicate. Now, if we plug in a specific value for n, we do get a statement. In fact, it turns out that no matter what value we plug in for n, we get a true implication in this case. What we really want to say is that for all values of n, if n is prime, then n plus 7 is not. We need to quantify the variable. In the next video, we'll discuss what exactly it means to quantify a variable. So I'll see you then.